topic?
No, sir.
Okay. So I think we completed the linked list few days back. So at that time, we just completed only singly linked list, like how it is implemented internally, that we discuss, but there are few other type of linked list as well. Those we will try today. This is a little bit, you can say, coding question are not asked from these topic, but in interview they might ask these concepts about different types of linked list. Once we will complete this, then we have few topics left. The first one is very important topic, tree, then graph, dynamic programming, and at the end we will try to cover the OOPS concept, and if time permits we will discuss, we will study one more data structure that is called as try data structure. This is advanced data structure. These all are advanced only, but if time permit, we will discuss about this particular data structure as well. Correct? To understand these data structure, you should be very good in the recursion part. So before we will start tree or any other advanced data structure, practice recursion. To solve this tree questions or graph question, you have a fair understanding of how recursion works. If you know that, you can easily do the questions of these data structures. Correct? So today we will try to discuss about few other types of linked list. The first one is singly linked list that we already discussed. The second one is circular linked list. Why we are going to the circular linked list? There is a disadvantage in the singly linked list. What is the disadvantage here? Please listen carefully. Suppose there are 4 nodes. Now let's say this is 10, 20, 30, 40. Let's say these are the addresses 1K, 2K, 3K, and 4K where these nodes are created. We'll put 2K here. This particular node will point to this particular node 2K. Node 20 will point to 30th one, and 40 will point to 40th one. This is the, you know very well, tail pointer. This is the head pointer, more or less. These things you know. Now, what is the disadvantage here in case of singly linked list? For example, let's say you are standing at this particular node, suppose. If you want to traverse the whole linked list now, you can't. Because if you have this particular node address, let's say some temporary node equal to 3K, you are standing at this particular node. Now, if you want to traverse the whole linked list using this particular node, then you can't access other node except 3K and 4K. You can access these 2 nodes only because you are allowed to move in the forward direction in case of singly linked list. Correct? To access the complete linked list, you should know the head pointer. But this is the disadvantage in the circular linked list. In the singly linked list. To overcome that, they introduce circular linked list. Let's discuss that particular concept also. I hope that you got the meaning, like why we are introducing circular linked list. The disadvantage, we can't traverse the linked list from any node. We can traverse only from the header node. So let's discuss the circular linked list implementation. In circular list, what will happen? Your last node will point to the first node. Your last node will point to the first node. If this is the case, then what will happen? You can put here 1k, that is the head node. If you do that, then this particular node will point to this particular node. Now, if you are standing at 3k, you can easily traverse the whole linked list. How? Same thing. Maybe you can write while temp.next is not equal to this particular node, let's 3k, until you will traverse, correct? What you will do, you will just say so temp.data and go to the next node, temp equal to temp.next. This is the thing that you will do. What is the meaning here? Listen carefully. You are standing at 3k, temp equal to 3k. 3k dot next is 4k. 4k is not equal to 3k. That is correct. You will go inside the while loop. You will print the temp data. Temp data is 30 here, and go to the next node. Next node is nothing but 3k. Next is nothing but equal to 4k. Now we will stand here. 4k dot next is nothing but 1k. 1k is not equal to 3k. That is correct. So you will go inside the while loop. You will print 40 here. Go to the next node. Next node of 4k is nothing but 1k. 1k next is 2k. 2k is not equal to 3k. That is correct. Go inside the while loop. Print the data. Data is 10. And go to the next node. Next node of 1k is nothing but 2k. Now 2k next is nothing but equal to 3k. 2k dot next is not equal to 3k. What you will do, you can see that 2k next is equal to 3k. 3k equal to 3k. 3k is not equal to 3k. It is false. So we will came outside of this particular while loop. And maybe you can print the data of the last node here. Something like you can just write so whatever temp dot data. So if you print here, 2k data is nothing but 20. Now here you can see that it will traverse the linked list from any node. It's not mandatory to be on the head node in case of circular linked list. I hope that is clear. If anyone has any doubt, please let me know. Any doubts? Okay. So if they want, for example, let's say in the interview, they are saying implement the circular linked list, then I think you can easily implement it, right? Implementation in the sense you have to implement the insert delete functions, right? You can easily implement the insert function. Insert at beginning. So at this case, what you will do, you will simply write, very well. For example, let's say there is already one node here. Let's say 10, and initially, let's say it is null. If there is one node, then in that case, in case of circular linked list, the last node will point to the first node. So in this case, this particular node will point to itself. That is nothing but equal to 10. Let's say 1k. Now let's say you want to insert one more node at the beginning. What will happen? You will do something like this. You have the head pointer. Let us this is created at 2k. Data is 20. So what you will do? Whatever node you will create, you will just write node.next equal to head. So this is your head is nothing but it will be equal to 1k. Update the head with the node head equal to 1k here. Now your head will point to this particular node. Now you have to update the last node also. For that you are maintaining the tail pointer as well. So just update the tail with the new node. So tail dot next equal to whatever node we are putting here. So we are putting here 2k. So it will be 2k. No, it will point to 2k here. Something like this. That's it. Nothing else. So this is the head here and this is the tail here. If you want to insert one more data, same procedure. Let's say the node is created at 3k, data is 30, node.next equal to head is 2k here, so it will be 2k. This node will point to this particular node. Then we have to update the head is now updated to the new node, that is nothing but equal to 3k, and update the tail pointer also, tail will be equal to tail.next equal to node, that is nothing but equal to 3k. So if you do this, then this will be updated here with this particular one. That's it, nothing else. Head, tail, everything you have. Insertion is happening in order of one time if you are inserting at the beginning. This is the method that you can easily implement. Anyone has any doubt in this particular approach to insert a node at the beginning in case of circular linked list? Seems okay. Now, the second function is insert at end. In that case, for example, let's say this is the initial linked list 1020. This is created at 2k, this is created at 1k. Obviously, this is the 2k. And this is the head node, and this is the currently the tail node. And tail dot next is always point to the head node, that is nothing but equal to 1k here. Now suppose you want to insert one new node here. What you will do? First, this is the new node. Let's say it is created at 3k, data is 30. What you will do first, you will just update the tail. Tail dot next, you will just connect this particular node with the tail node. Tail dot next equal to new node here. New node is nothing but equal to 3k here. So you will just write something like this. Or before that, maybe you can just update the just circularly connected. You can just write new node, this particular node dot next equal to whatever tail dot next. So here you can see the tail is nothing but 2k. 2k dot next is nothing but equal to 1k. So we'll put 1k here. When you put 1k here, immediately this particular node will point to this particular node. Then you will update the tail node. Tail node dot next equal to new node. So you will update 3k here. Once you will put update 3k here, this link will be created. Then update the tail node. Tail node is nothing but equal to new node, something like this. Now your tail is updated here. This is what you have to do, nothing else. This is the insertion at the end which you can perform. More or less, you have to take care of the last node, that the last node will always point to the first node. Correct? Anyone has any doubt here?
No, sir.
Insert at index, I think that you can try. For example, let's say this is index 0, this is index 1, this is index 2. For example, if you want to insert a element at index 2, then in that case, we want the node which is present at index 1. We want that particular node which is present at index 1. Maybe we want this particular node address, right? Whatever we did in the insert at index function in case of single linked list, the same way we'll do here. We'll find the index, we'll find the node which is present at index -1 position. Then I think it's a cakewalk for you. If you have that particular index, if you have the node at index -1, let's say this particular node is temp node. You have this particular node here. What you have to do here, simply you have to insert like this. Let's create one node here. Let's say this particular node is created at 4K and data is 40 here. What you will do, because this is not the last node, this is intermediate node, we don't have to change the head, we don't have to change the tail. We have to just update this particular node will point to this particular node, and this particular node dot next will point to this particular node. How we'll do this? We'll just write this particular node new node dot next equal to whatever the previous node pointing. So here you can see that the previous node is nothing but temp dot next. So what is temp here? Temp is 2K, 2K dot next is 3K. So we will put 3K here. So this particular node will point to this particular node. And then the previous node, that is nothing but temp dot next, will point to this particular new node. So temp is nothing but equal to 2K here, 2K dot next is equal to 4K. So we'll put 4K here. Immediately this link will be created and this link will break. And this is how you can insert any node at a given index. What is the trick here? You have to find the node which is present, which presents at index -1. That I think you can do, that we already discussed. This is the insert function. Similarly, you have to implement the delete functions. This is how we can implement the circular linked list. What is the advantage here? We can traverse the linked list from any node. This is the advantage of circular linked list. We can insert the item at both beginning and the end in order of one time. Now let's move to the other part here. The other type is known as doubly linked list. Why this linked list come into picture? Please listen carefully. In the last example, when we are finding out the node present at index position maybe, or in case of circular linked list or single linked list, we are allowed to move in the forward direction, not in the backward direction. Something like this. This is 1K, 2K, 3K, 4K, 10, 20, 30, 40. This particular node is pointing to 2K. This particular node is pointing to 3K, 4K. If it is a single linked list, then this will be null. If it is a circular linked list, then this will be 1K. Any linked list. Now, why we are going into the doubly linked list approach? Please listen carefully here. If you are standing at any node, for example, let's say you are standing at this particular node, then you are allowed to move only in the forward direction. From this particular node, you can go to this particular node only. But you can't go back. You can't go to the previous node here. If you want to go, you have to completely traverse the linked list and then you can go here. For example, let's say we want to go to node number 10, then how we can go? We can just from 20, we can go to 30, 30 to 40 and 40 to 10. We have to completely traverse the linked list and then only we will go to the previous node. And to find the previous node, it will take order of n time always. Correct? So this is the disadvantage here in case of singly linked list and the circular linked list. To handle that, we have one more type of linked list that is called as doubly linked list. There the node structure is a little bit different. Let's try to understand that first. Let's name we have to create one class here, class. Node structure is different. That's why we'll create doubly linked list node here. Here we will put something like this, int data. That is the one thing. And here we can go in the forward direction as well as in the backward direction. So we will maintain two pointers here. One is the previous node pointer and one is the next node pointer. So we will write here something like this, doubly linked list node previous. In the middle, we will maintain the data. And at the end, we will maintain the next. This is how your node will look like, right? This. Let's say this is we created one node here at 1K address. Let's say the data is 10. This particular will point to the previous node. And here this particular will contain the address of the next node. That is next and that is nothing but previous. Now, if you are standing at any node, you can go to the previous node in order of one time. You can go to the next node also in order of one time. Let's try to do that. Maybe we can implement the linked list and then we will see. So for that, I'll create one class and then I will show you how we can insert and delete from the doubly linked list. I'll share the Eclipse screen now. Class 35. Import java.util.star. Today's date is 24th of March. What we will do here, we'll first create the node structure. So we'll create double linked list node. The first value is nothing but the previous pointer. In between, we will put the data and then we will put the next pointer. Let's create a few functions here. Let's say public static void insert at beginning. Insert at end. Insert at a given position. To implement this, we will have the two pointers. Obviously, we will take two pointers. The first one is nothing but the head node. The second one is nothing but the tail node. Maybe you can take the size also if you want to implement the size. How to insert a node at the beginning? Listen carefully. We'll write one node here, something like this. Let's say this particular node is created at 1K. Initially, the header node is null. So obviously we know that the linked list is empty. In that case, we can directly insert the data and your head and tail will point to this particular node. Head also and tail also. If you are inserting one more data, let's say you are inserting at the beginning, what you will do? You will create one node here. The node will be created at 2K. Let's say the data is 20. What you will update? You will update the this particular node previous pointer, this particular node next pointer. Let's write that first and then we will see. Listen carefully. If the head node is null, it means the linked list is empty. Then in that case, what we will do? We will create the new node here. Simply and update the head pointer and the tail pointer. That's it, nothing else. So maybe here we have to create the constructor also because we are initializing. Let's say public DLL node int data. We'll just mark this dot data equal to data. Obviously, by default, the value of previous and next node is null. If you want, you can write here this dot previous equal to null, but by default these values are null because these are nothing but object by default value is nothing but null here. Correct. So here we will write something like this. If head is null, then in that case we will update the head and tail with this particular value. That is nothing but the node which we created. Something like this. Otherwise, what we have to do, please listen carefully. First, we will write something like this. This particular node which we created, the next value is equal to whatever we are pointing in the head. And head dot previous equal to this particular node. Update the head to this particular node. Let's see this particular operations sequentially. Here what we did, this is nothing but the new node dot next equal to head. What is head here? 1K. This link is created here. Head dot previous is equal to new node. This is 2K. This link will be created like this. And then update the head. Head is nothing but equal to now 2K. And maybe you can increase the size whenever you are inserting any data into the linked list. So you can just increase the size plus plus. That's it, nothing else. This is how we can insert the data at the beginning. If you want to insert at the end, how we'll do? For example, let's say we create one node here. Node is created at 3K. This data is suppose 30. How we will do it? Let's try to write the code for the same. You can write something like this. For example, let's say the head node, if anyhow the head node is equal to null, then in that case, the new node will be the head node and the new node will be tail node only. That's it. That's what we have to do. Head equal to tail equal to that particular new node. Whatever we will create here. Something like this. Otherwise, what we will do, we'll just write tail dot next equal to whatever node we are creating and node dot previous equal to tail and update the tail with the node value. Something like this. Here you can see tail dot next equal to node that is nothing but tail is nothing but equal to 1K. 1K dot next is equal to 3K. So this particular node will point to this node. 3K is nothing but node dot previous equal to tail. 3k previous is equal to tail. Tail is nothing but 1k, so we'll update 1k here. Tail equal to node. Tail equal to node here. This is nothing but tail now. That's it. And at the end, maybe you can increase the size. This is what you will do to insert a given node at the end. If you want to insert at a given index, what you will do? For example, let's say these are the indexes now 0, 1, and 2. Let's say you want to insert a node at a given index. That is nothing but, let's say, index 2. In that case, what we want the node that is present at index -1 position. Once we got that, then I think we can easily insert a node at the given index. So we'll write here something like this. For example, let's say if index is less than 0 or index is greater than size plus 1. Whatever size we are writing here, if it is greater than 1, then these are nothing but invalid index. Then in that case, we can't insert any data. So we can just simply write system.out.println invalid index, and we can simply return. If index is equal to 0, it's nothing but we are trying to insert a node at the beginning. So I'll just write, call this particular function, and we'll pass the data here. That's it. Else if index equal to size, then in that case, we want to insert at the end, we can simply write something like this, and we'll pass the data here. Else means this is any intermediate index. In that case, we want to find out the node present at index -1 position. So maybe you can take one count variable here, int count equal to 0. While count is less than index, we have to do something like this. You can take one temporary node here, maybe node temp equal to head node initially. And we'll write here something like this, temp equal to temp.next. For example, let's say we want to insert at the index 2 here. Initially count value is 0. Temp is nothing but equal to 1k. 0 is less than 2, yes. We'll go to the next node. Next node, temp is nothing but equal to 2k because the head is nothing but 2k here. 0 is less than 2, yes. Temp equal to temp.next. 2k next is nothing but equal to 1k. We will increase the count also here. After this, what will happen? 1 is less than 2, yes. We will go to the next node. That is nothing but 1k next is nothing but equal to 3k. And we will increase the count also. That is 2. 2 is less than 2. That is false. So you will reset the second index now. And whenever you will reset the second index, you can easily find the previous node from that particular index here. So we'll write here something like this. Increase the count also. Once you will do this, you will reset the index node and you will find the previous node. How you will find the previous node? You can simply write node previous equal to temp dot previous. That's it. So now you have the pointer to this particular node, that is nothing but previous node. Now if you want to insert a new node here, how you will insert? Please listen carefully. You have the temporary node is pointing here right now. The previous node is pointing to this particular node, and this is the new node that you want to create. So let's create that particular node first. DLL How you will write here, we have to update the previous and next pointer here. For example, let's say we want to insert one more node. Let's say the node is created at 4K address. Data is 40 here. Now we have to update the previous also, next also, and this previous also, and this next also. Let's write one by one. Listen carefully. This particular node previous value is nothing but equal to the previous node. This particular node next value is nothing but equal to temp node. So here we created the links. What will happen? This particular node 4k.next is equal to previous. Previous is nothing but 1k. So this link will be created here. And 4k next is nothing but equal to temp node. This is nothing but 3k here. Something like this we created. Now we have to break these links and somehow we have to do like this. So what we will do? Now we'll update like this. Temp.previous equal to this particular node. So we will update the 3k previous equal to 4k. So this particular link will be created here. And the previous node dot next equal to this particular node. So this link will break and it will point to this particular node. That's it, nothing else. And this is how we will insert, and at the end we can increase the size. That's it. This is how we can insert a node at the given index. I'll just implement one function to display public static void display, which will print the linked list from head to tail. Let's take the temporary node here, which will point to the head node right now. Same logic we will write while temp is not equal to null. We'll just write system dot out dot print temp dot data. We'll go to the next node, temp equal to temp dot next. That's it, nothing else. And once we'll came outside of this particular while loop, maybe we can print a new line also here. This is how we can implement the display. Here we are implementing the tail also, but nowhere we are updating the tail here. I think we are updating the tail here, right? That is correct. So this is how we can do. Let's try to call this particular function. Insert beginning. Let's say we are inserting at 10 at the beginning, then insert 20 in the beginning. Then maybe let's say you want to insert 30 at the end. And then maybe you can insert 40 at index 2. This is how what we will do. Let's try to do this. Here you can see that if you, I think we have to implement the display function as well. We have to call this display function to see what is the values here. Let's try to run now. Here you can see that this is what is the linked list that we created: 20, then 10, then 40 and 30. This is the linked list for now that we created right now. Correct? Anyone has any doubt in these three functions, please let me know. Let's implement the delete functions as well. Let's say public static int delete from beginning. If you want to delete the node from the beginning, what all you have to do, you have to delete these links make this particular node as orphan node and then move the head to the next node. This is what you have to do. So for that, what we can do, let's store the double linked list node, the head node in the temp variable. You will simply write temp.next or just update the head here, maybe something like this. Let's say head equal to head.next. Now you will just write temp.next equal to null. Head.previous equal to null. Decrease the size. And maybe you can store the result of the temporary node in some variable. Let's say int deleted element equal to result this temp.data. And maybe you can return here, return the deleted element. Something like this we have to do. What I'm doing here, listen carefully. Initially, I'm storing the head node in the temporary node. So temp will point to 1K here. Then I'm moving the temporary node data into the EL variable. So it is equal to 20 here. I'm marking the head equal to head.next. Head will move to the next node. That is nothing but 2K now. Sorry, this is, I think, head is temp is 1K. Head is temp is 2K. Head is nothing but equal to 1K. 2K next is nothing but equal to 1K. Now temp.next equal to null. You are marking this as null. So this link will break. Then head.previous equal to null. This link equal, if you marking this as null, this link will break. At the end, what you are doing, you are decreasing the size and you have to mark the temporary node also as null. So you have to write temp equal to null also to make it as completely orphan node, correct? Maybe you can write that particular node also. And after this, what will happen? Your Java garbage collector will come and automatically delete these particular nodes. So let's write that also. Temp equal to null. We can add the validations here. If size equal to, or maybe let's say head equal to null, and still you want to delete the node from the beginning, then it's not possible. In that case, maybe you can just throw one warning system dot out dot println. Just say double linked list is empty. And return -1 from here. Obviously, for example, let's say there is only one node and you deleted that particular node. Then in that case, you have to see what is the size now. If the size is 0, then you have to update the tail node also to the default value head equal to tail equal to null. This is what you have to do to make the consistency. This is how we can implement the delete from the beginning function. Let's implement the delete from end also. Public static int delete from end. Let's say what we will do. For example, the given linked list, you can see that this is the last node here. If you want to delete the last node, how we will do that? You don't have to traverse to get the tail node, because in this case, if you want to update the tail node, you can directly go to the previous node directly. That is nothing but tail node previous. How you will go there? You will just write doubly linked list node. Maybe temp node is nothing but equal to tail node dot previous. Now you have the pointer here as well. If you want to delete this particular node, you have to update this particular reference that this particular node 4K next will not point to 3K. How we will do that? You can simply write something like this tail dot previous equal to null. Tail is nothing but 3k here. 3k dot previous is null. That is fine. Now this node is not pointing to any other node. Tail will now point to the temporary node. That is also fine. And temporary node, next value will be null here. We will decrease the size also. Once we'll decrease the size, we will check whether the size is 0 or not. If the size is 0, we have to update the head and tail. Head equal to tail equal to null. And at the end, we will return whatever node we deleted. So here we can maintain one element which will store the temporary node data here, something like this, and we will return this particular element at the end. We can put the check here by default, like for example, let's say if the head node equal to null, it means the linked list is empty and still you want to delete the last node, then this in this case also it is not possible. You can just throw one warning that it is not possible and return -1 here, something like this. This is what you have to do. Maybe update the temp also, temp equal to null. That is also not required now, something like this. So let's try to delete the node from the beginning and then from the end. Let's say we'll call this particular function delete from the beginning, and then we will call the display function. If you do this, here you can see that initially the linked list is 20, 10, 40, and 30. If you delete the first node, 20 will be deleted and the linked list will become 10, 40, and 30. Similarly, if you call the delete from the end function, and then call the display function, you can see that the last node will be deleted now. The last node here in this case is 30. 30 is deleted now. Now you have two nodes, that is nothing but 10 and 40. This is how we can implement the delete function here. If you want to delete the node from a given index, that also you can do. Just go to that particular node here at a particular index and then update the pointers. How we will do that? Let's write that particular function also. Then I think it will be kind of complete. So we'll write here public static int delete at index. We'll write the index here. For example, if the index is less than 0 or index is equal to size, then these are nothing but invalid index. You can simply write here, these are invalid index, the way we are doing here in case of inserted index. And in that case, you can simply return -1. If index equal to 0, it is nothing but in deleting the element from the beginning. Then in that case, you can simply call the delete from beginning function. Else if index equal to size -1, then you can call the delete from end function. And just write here something like this. Otherwise, if it is an intermediate index, then in that case, what we have to do, for example, let's say we want to delete the element, delete the node which is presented index 2. Example, in this case, let's take this particular example. Let's create the linked list here and then try to understand 2k, 1k, 4k, and 3k. These are the nodes we have. Let's say 2k, 1k, 4K, and 3K. This particular node previous is nothing but equal to 4K. It will point to this. This next is 3K. 4K previous is nothing but 1K. 1K next is nothing but equal to 4K. 2K next is nothing but equal to 1K. 1K previous is nothing but 2K. And this is null. Obviously, here you can see that this is the head node and this is the tail node. These are the indexes 0, 1, 2, 3. If you want to delete the node at a given index, first go to that particular index. Let's go there. We'll write here something like this. Maybe you can simply write something like this. Let's say int count equal to 0. While count is less than index, what you will do, you will go to the next node, traverse the linked list and just move in the forward direction. Let's say double linked list temp equal to, initially you want point temp to the head node. Then you will say temp equal to temp dot next. Increase the count here, count plus plus, something like this you will do. Once you will go there, your temp node will point to this particular node that is nothing but 4K here. Now, if you want to delete this node, then we have to update this pointer and this pointer. How we'll do that? First, we'll find the previous node and then we'll find the next node. So we'll write here something like this. Double linked list. Previous node is nothing but equal to temp dot previous and double linked list. Next node is equal to temp dot next. What we have to do here, we have to simply connect this particular node, the previous node with the next node here. That is nothing but we have to break this link. This particular node will point to this and this particular node will point to this. That's what we have to do. So for that, we can simply write here previous node dot next equal to whatever next node we have, and next node dot previous is nothing but whatever previous node we have. This is what we have to do simply. And then maybe you can just point the temp node as null. Or if you want to store the data, maybe you can just write int el equal to temp dot data. Decrease the size. Return el from here. That's what we have to do. Let's try to write the same also. Delete at index. For example, let's say if we are not deleting anything, and if we will delete the node at a given index, let's say 2 here, then if we call the display function, it will print 20, 10, and 30. Node 40 will be deleted here. Let's see here. Here you can see that 20, 10, and 30, 40 is deleted here. This is how we can implement the delete at any index function. So this is how we can implement the double linked list. Maybe if you want to implement the function where we are calculating the size and all, let's say public, that also you can do. Static int size. This is nothing but if you want to calculate the size, then you can return whatever the size here. That is nothing but size here. There is one more function that is public static boolean is empty. What you will do, you will just calculate what is the size here. So we'll just write if the size is equal to 0, then it will return true. Otherwise, it will return false here. Correct. So this is how we can implement all the functions in the double linked list, and this is how it will look like. What are the advantages here in case of double linked list? You can see that we can go to the previous node in order of one time. We can traverse in both direction. We can traverse in forward as well as in the backward direction, and we can go to the previous node in order of one. Unlike in case of singly or circular linked list, if we want to go to the previous node, then we have to completely traverse the linked list. But here it will take only order of one time. There it will take order of n time. These are the advantages of double linked list. Anyone has any doubt on this topic, please let me know.
No,
No,
sir.
sir.
No, sir.
So this is what okay, this is what is missing from the linked list. I think this is covered now. If someone, if from, I think the interview will ask like, if you want to, if you can implement this double linked list or circular linked list, then I think you are in that particular situation now that you can handle those questions, right? In case of time complexity, or if he wants to implement, then I think you can easily write these functions, right? So this understanding you should have. There is one, I think, question based on doubly linked list also that I will share, or maybe I will explain that in the next class or whenever we have time. I think if you go to the high level design questions or low level design question, there is one question to implement the cache or maybe something like this. How cache is working, right? There is something called as cache in you can say that memory, right? How things are stored in the cache. I think internally in cache we use the double linked list. So that concept we will discuss at the end of the course. That might be useful for you. Yeah, this is about today's class. Rest we will see. I already shared the code on the group. I think you will get the code by tomorrow morning in your respective channels from the management, right? Okay then. Yeah. Thanks everyone for joining the class on time. Bye.
Thank you, sir. Bye, sir.
Yes, sir. Bye,
Thank
sir.
you, sir.
Right.